Perfect. So hello, everyone. My name is Valay. I work for Outer Bounds, and I'm a software engineer. Prior to Outer Bounds, I was at Arizona State University pursuing my master's degree in AI and machine learning. And at that time, I came across Metaflow, where I have been building a lot of projects in and around Metaflow for the past 2.5 years. And right now at Outer Bounds, our main mission is to build stuff and a platform around Metaflow. So in this talk, I wanted to first give a brief overview of what Metaflow is and how you can use Metaflow, and then provide a peek into how you can use Slack along with Metaflow to monitor your machine learning workflows that might run for a very, very long time. So giving a simple outline of what the talk will be about, where initially at the start, I'll first focus on why ML workflow orchestration is hard and how Metaflow comes in to plug in a lot of gaps in ML workflow orchestration. And after that, I will provide a small demo on how you can use, for example, Metaflow to do machine learning, where in this demo, for example, I'll create music videos using a state-of-the-art machine learning model called as BigGAN. And after showing a small demo of how machine learning workflows are orchestrated using Metaflow, I'll show a few demos of how you can use Slack as a way to monitor these workflows and even visually see the artifacts that have been created as a byproduct of these workflows. So coming to the main elephant in the room and like the main question, which is why ML workflow orchestration is hard. And one of the first key insight that I feel, which is very important, especially from this chart, is that machine learning as a field is not super duper old, in a way that obviously people were doing ML more than a decade ago, but the amount of hype and the amount of interest in machine learning has grown across the past decade, especially after the release of the first really powerful computer vision model known as AlexNet. Now, after AlexNet's release, the entire research community, as well as a lot of even industrial people, started aligning themselves towards using all these deep learning like methodologies to solve not solve, but at least approach different problems in the space. And because of that, over the past 8-10 years, as you see, the size of our machine learning models have become bigger and bigger and bigger. Now, one of the reasons these models are able to play so well with like such large sizes is because we can adapt them to large enough amounts of data. But one of the main nuances that comes about when we start thinking about these models and very large sizes is that even though we start getting really good performance by just stacking more layers, there are certain non-trivial problems that keep coming around if you start scaling these models. And even though at times we would want our models to scale and work as well by just doing a tiny tweak on our command line by saying python model.py -- super large model running on my huge cluster, achieving this type of an abstraction is much harder. So other than the fact that scaling is pretty hard for these models, it starts becoming a very ugly story once you start handling a lot of the DevOps around machine learning itself, meaning how you allocate compute, how you set up schedulers, how you how you even do, for example, version control around the DevOps of ML. So outside DevOps, if we start even thinking deeper, that if we want to reproduce our results from whatever we do in ML, we have to ensure that we have the right dependencies, that get bundled along. Because this is the other problem where you might be able to run something on your local computer, But as if you move it into a production environment, you need to ensure that all the dependencies are frozen and everything works as is so that you can get the same result again and again, which again, in machine learning, with the way optimization takes place in all these models, sometimes it's much harder. So other than even like simpler things like dependencies or like even just allocating compute for these models, there is other like more itchy problems that come around, which is that if you write code, you are going to have bugs in your code, which is like any developer who ever types code will always have bugs in their code because it's always hard to not try. It's always like, I feel that it's the only code which has no bugs is no code actually. So if you write code which will have bugs, then whatever software that you build which has some machine learning component in it, it has to have a way to handle fault tolerance much better. And fault tolerance is such a thing that building it intrinsically inside some software or inside some framework is much harder. So making machine learning models bigger also brings us with this problem where if we have some bug in our code, our entire model training can break at the end moment, which can result in a loss of state. And this loss of state can sometimes be really expensive because training these models sometimes over GPUs, over large clusters, maybe sometimes cost even a few hundreds of thousands of dollars or even $1 million. Like for example, with GPT-3, where training GPT-3 apparently costs more than a few millions of dollars. So in such situations, if you have buggy code, then it's a big problem to recover all the state that you might have lost. So in order for users to do machine learning well, they have to ensure that their models keep getting checkpointed and their code is not buggy, which is even harder. And finally, which I feel like this is the most important thing as a software engineer, is the whole notion of version control, where in today's day and age, machine learning is not just the model in itself. It is the data that goes inside the model too, and all the steps you take before that for pre-processing, setting hyperparameters, etc. Now, in such a situation, if you want to understand if your model is getting better or worse, or if there has been some bug that got introduced in the model, you don't need to just version control your code. You have to even now start thinking about version controlling data. So in a general sense, that if you're building machine learning and you have no form of version control, then who would need version control, right? So but to have to do it in a very concrete and a scientific way, there requires a necessity to have some form of version control built into your code, which nowadays is harder to find off the bat. And finally, it's like once you, for example, even if you set up all of these different types of things, it's important to start monitoring what is going on with your workflows around machine learning. So if you don't have a monitoring system, it is harder to even get to know harder to even get visibility if something wrong is going down or not. And so based on all these problems that I had just stated, this is a very great segue to explain that in general, if we look at the landscape of data science, ML and AI, practitioners of data science, ML and AI care very little about the actual infrastructure needed to do the art of ML and AI. But they rather care more about the more important parts of their jobs, which may be model development, feature engineering, and even versioning. And this is where the actual business needs are totally different, where in to act like the engineering needs are totally different, where for example to actually do well machine learning really well, you need to have good compute, you need to have a warehouse where you can store data, you need to have a scheduler which can ensure that jobs get scheduled at the right time and in a fault tolerant way, along with some form of versioning that ensures that all your data artifacts, along with your code artifacts, start getting versioned. And this is where Metaflow comes in place. So the entire idea behind Metaflow was to allow data scientists to be creative and productive while handling everything else underneath the stack. And And this is the other thing where generally it's these are things where, for example, we think about versioning, job scheduling, compute resources, data warehousing. These are such types of areas where we may not even expect, for example, a PhD data scientist to have domain expertise, because these are generally parts which software engineers generally deal with. So the whole goal behind Metaflow was to provide a systematic API which ensures that users don't have to worry about all these underlying parts of the technology stack, while they only care about stuff which is going on top, which is the architecture of their code, to the way they are handling the operations around their models, to the feature engineering and the actual model development. And this is where I wanted to now explain how Metaflow actually works, and like how we bring in all these very interesting features of, version control, job scheduling, like data warehousing, even compute allocation, through one simple framework. Now, there are a few concepts I wanted to introduce around Metaflow, which are very general purpose concepts. So, for example, a flow spec is in short a workflow, and it's more like a directed acyclic graph. So users, if they want to write a Metaflow workflow, they would inherit a flow spec object, and outside of a flow spec object, whatever functions that they want to ensure are a part of their directed acyclic graph, they annotate those functions using a step decorator. So for example, in Metaflow, it is important to have a start and an end step. And the self.next that you see is defining the edge between two nodes in our directed acyclic graph. So in our simple linear flow, we wanted to first process some data, set that data as our artifact over here with self.dataset. Then we wanted to train some machine learning model. And then finally, we wanted to be done with it. So this is how we create a simple linear flow. And this works, for example, on your local machine, where you are initially prototyping your code to create, like, just to see if stuff is working. Now, after some point of prototyping, you came to realize that, okay, my model is basically, the dry run is working perfectly fine. I now want to check and see if I am able to actually deploy and run and train my model for a long enough period of time. So one very nice way to do this is via Metaflow is to just directly start using internal constructs of Metaflow, such as AWS batch, sorry, not such as AWS batch, but such as the batch decorator. The batch decorator is basically a hook onto AWS batch, where annotating, for example, this step with a batch decorator will ensure that this step will run on AWS batch as a container, which will have a 12 CPU allocation with an allocation of 20,000 megabytes of memory and 4 GPUs allocated to that job. Now, because we are able to fine grain allocate computational resources, we are now, because of that, we are able to ensure that our jobs get scoped to how much ever resources we want to provide them. And this also ensures that we, for example, as a user, if I want to train a model in a very large cluster, like not in a large cluster, but like, for example, with a lot of GPUs, versus after its training is done, I don't want to use a lot of GPUs, I can afford doing that with Metaflow, because all I have to do is just annotate my step. So for example, in this workflow, the training step will now run on batch. And now, for example, after doing this, I realized that, okay, there are a few hyperparameters that are there that I want to like see how my model will perform based on those hyperparameters. Then one very simple thing I can do is use constructs inside Metaflow, such as a for each, to actually fan out my search for the right model. So giving an example over here, our start step, for example, processes and creates some data, after which we, for example, the self.hyperparameters is allocated to objects. Now, when we do self.next with a for each like with a for each argument, this basically ensures that the train step, for example, will have two parallel executions running for jobs, and these will parallelly train two different models, for example, for my two different hyperparameters that I have right now. Now, the other thing is that outside of just fanning out to, search for more things, Metaflow also offers a way that you can join all of these steps that you have fanned out into. So for example, as you see on the side on our DAG, if we have, as we have, for example, all these parallelized training runs, once all the training runs are done, we can collect all of the results of these runs together and, for example, select the best model. So the task results in the select model step is like a list of all artifacts generated by the train step, and select best model will, for example, help us find out which is the best model, and we can then allocate it to Metaflow's self.model property, and then we can now, after that, easily access the model once our flow has completed running. So giving an example of how we access information after our flows are done can be seen over here, where after, for example, we finish running our Metaflow flow, we can access the artifacts using either the flow object or the run object. Now, for example, over here, as you see, the run consists of linear flow /12. So what that basically means is that every flow, like whatever the name of the flow, after that, whatever slash we put, after that, after the slash comes the ID of whatever run that was created. And what that means is that when you instantiate a flow and actually run it, the whole version control happens at that time, where every artifact that is created within the flow, for example, over here, self.model, which has been created within the flow, are all checkpointed according to which instantiation of that run it was. And then you can easily access that using Metaflow's APIs via the flow and the run objects. So like just recapping until now what I have explained, which is that via Metaflow, you can create all these fancy types of machine learning workflows, which can be scaled out, which have internal version control, as well as fault tolerance as an intrinsic part of it. And in any case, if your flow ever fails or like crashes at, for example, the train step, Metaflow consists of these internal APIs which allow you to resume from the point of failure. So for example, if my train step failed, where out of the two, for example, parallel training runs, one of them failed, I can resume from the one which failed, and basically the one which had completed will anyways would have been checkpointed. So I do not lose state, especially if my training, for example, is expensive. Now, now that I've explained how the basics of Metaflow work and like what is the high level intuition behind the way the library has been devised, I wanted to give a small demo of, for example, one use case, which may be in computer vision, for creating music videos using some state-of-the-art deep learning model known as BigGAN. Now, obviously Metaflow can be used for a lot more use cases outside of computer vision too. But this was just one of those where I felt that because it's a machine learning with a deep learning sort of a workflow, it is a great example to showcase how Metaflow's different capabilities can help for managing all these different pain points that come around with ML. So to make it very simple, the entire idea behind this problem is that nowadays, with the new advent of these models such as OpenAI's Clip and DALL-E, you can generate videos or you can generate images using just simple text descriptions. So the idea was that I wanted to give my model, I wanted to give a text description, some audio file, and a pre-trained model. All right. And using these three pieces of information, I wanted to create a final music video. Now, because all these Clip and DALL-E like models allow me to fine tune them on text descriptions to create images, the way I orchestrate this workflow is very simple. That I first fine tune my model, all right, where I can scale it up to do GPU training. All right. And after I scale it up to do GPU training and the job finishes, and I have this fine-tuned model. What I wanted to do after that was that instead of going by lyric or by description to generate my entire video, I wanted to break up all the descriptions into smaller chunks so that I can parallelly run inference and basically generate my video chunks. And so one thing I do after fine tuning the model and creating the actual machine learning model for inference is I generate separate individual video chunks using Metaflow, where we do a for each over the number of lines of description that are there. And in each of these steps, we individually create a chunk of a video. So once we have created these, and once this entire for each fan out finishes running, we join all the video chunks to create one singular video, and that is the final output of our flow. So simplistically saying, first comes the training, then comes just like an inference step where we can do a fancy fan out, and then comes the final join where we, for example, gather all the artifacts together to create one final video. So I wanted to now go and give you guys a demo. And again, at any time, if you have any questions, please feel free to like just ask. It's perfectly fine. So coming to the code, so this is this file that you see over here, which is videocreator.py, is the main file I'm going to show for this demo, which consists of the flow I've written for Metaflow. Now, until now, I've explained all these different constructs around Metaflow, such as a step and a flow spec. I will also now explain other constructs in Metaflow, such as a parameter, where if you, for example, want to ensure that there are certain parameters that you want to, like, if you want to parameterize, for example, your workflow, where, for example, I want to say that I want to select how many GPUs, for example, go to my training step, or how many epochs do I train my model for, then I can create these parameters as a part of my flow. So every time I will run my flow, I'm allowed to add these as command line parameters. So giving an example, as you see on my command line over here, when I can, after I allocate a parameter object to any of the properties in my flow, I can access that, or I can provide them at the command line for So few parameters I had added to my workflow were epochs, for example, what generator I wanted to use while making these images or for fine tuning. Interpolation basically stands for how many images do I want to create between two descriptions at different timestamps. And text file, for example, is an include, so for example, include file is another type of object that we expose, or another type of API that we expose, which allows users to directly specify files that they want to use as parameters. So one of the reasons this object is very useful is because you don't duplicate your parameters at the backend when you are running stuff, especially if those parameters are actual files. So I include a bunch of these parameters and a bunch of these files as a part of instantiating my flow. And once it has been instantiated, I run these separate steps, which includes a start step where we, for example, create our data set on the video. For example, we create our descriptions exactly as we want them to be, like the data structure we want them to be, after which we actually go ahead and train our model, and we save our model, where, for example, as you see over here, we are actually saving our model at this step. And once we save our model on this step, we fan out for inference, where each, for example, description that we have, we spawn an individual container which has our model in it, and then we use our model in this individual container to actually do inference and create our chunk of video. And finally, once we have created all these individual chunks in our, for example, this video build video chunk step, we create the actual video in this join step, which is video from lyrics, where the idea would be for every input that was provided, we take in all the videos that have been created. And then once we take in all the videos that have been created, we concatenate all these videos into one singular video and then store it into S3. So giving, like, I wanted to run this once to show how the whole thing works. So for example, at the moment, I have checkpointed my files onto S3. And this is now starting my workflow where for 4078, for example, is the ID that has been generated for this individual instantiation of this flow, which is the run ID. Start is the name of the step that we have annotated, which you can see here. And the ID that follows that is called a task ID, which denotes what is the actual. So every instantiation of an individual step is called a task. And a task basically represents the actual information that gets logged once you are running that step. So right now, as you see, this is running on batch, where we can even provide an image for whatever container that we are spawning. And this image basically then easily helps us resolve the environment that we want. Metaflow also provides other ways for environment and dependency resolution via Conda. But for at least for this purpose of this demo, I have just used Docker images to make it easier. So as you see, for example, right now, our step is starting. And once the step starts, it'll show me a few log messages on, it's setting up environment and the rest, and it'll keep continuing. So for this brief moment, I want to first just ask if there are any questions, and then I wanted to go forward explaining more.
Is each step running like in a Docker container, or how is it isolated from other steps?
Oh, yes, exactly correct. So each of these individual steps are right now running in a Docker container because I've done at batch. Otherwise, if I'm running it locally, it will spawn a separate process.
Okay, so you can run the same code locally and also in the cloud.
Exactly that. So the whole goal was that you have to do very minimal touch-ups to change your code from local to production. So you can even experiment as close to production as possible using, for example, such annotations like at batch.
One question I have is, are these images pulled from Docker Hub, or do they need to be on AWS ECR?
Oh, so this one is on Docker Hub. And so you can choose, you can even feed ECR images, you can even feed Docker Hub images, both are fine.
And in the parameters, I saw one option that you have env vars. You just tell me what that, is it picking up from the environment variable as an option?
Yes, it is.
I think it was the first parameter you have.
1 second.
The num GPUs.
Oh yeah, correct. Yeah, this is picking up from environment variables.
All right.
So just one more note based on what you asked, which is a very great question. So Metaflow uses click as the internal library for invoking stuff from the command line. And the parameter object is more like a abstraction or like a wrapper over the click.options object, which basically allows this env var property. So yeah.
Got it. Thank you.
Any more questions, or I can go ahead? Okay. So right now is a great segue now to show the way you can start even monitoring these types of workflows. So at the moment, as you see on the left hand side, that my start step, for example, finished running, and now I have reached the train step, where it has deployed this train step onto the train step is now in the runnable state, so it's on AWS batch, and now we are just waiting for it to start run. Now imagine that, for example, at this moment in time, you as a data scientist, you just deployed your jobs, and you have to now go do a grocery run, and then there are some other kind of errand that you might have to go do. Now, at this moment in time, you don't know what is going on with your flows, and you might have to deploy something business critical that day, and you want to start monitoring your workflows. So one way you can start doing that is via the Metaflow bot that we have recently open sourced. Now, the entire idea behind the bot was to keep it like very minimal effort for users to start using, to be number one. Number two being that users should easily be able to extend the bot. And number three is that users should easily they should not have any friction once they to start using the bot once it has been installed. So in it right now, I wanted to give a brief idea on how you can start using this bot after installation. So the simplest way to start working with the bot, even over your local machine, is by just doing a pip install. All right. So once you do a pip install, we have a bot installed. So the way I start running the bot is via this simple command where I need to provide, for example, what is my email address on Slack. And one second, let me just. And I need to provide access tokens and bot tokens for Slack. If you want to know more about how to create these tokens, I would recommend please have a look at the documentation, because where we have given a thorough walkthrough on how you generate these tokens on Slack. But at least for the purpose of saving time, I will not go explain how these tokens are created on Slack. But once you have these created, you can instantiate, or you can start the bot. So I, for example, started the bot at the moment, and you guys can still see my screen, right? I'm just like clarifying. So
yeah, I see the Slack.
Okay, perfect. So for example, let's say I create a new channel, and now this channel has, for example, for example, our bot's name is Flowy, and let me, for example, just invite this bot to this channel. Now, one way I can start doing stuff is by just saying hi, and the bot will start replying. Once so for example, if I want to first start seeing what is happening with my flow, I can always just ask the bot to inspect the name of this flow. So the name of the flow is video generation pipeline. So I asked the bot to check up on this. And so the bot says that, okay, it's found all of these different runs over some time recently. Now I say that, okay, show me what is happening with this run. And now what the bot will do is it'll actually go check, and it'll figure out that, okay, at the moment I have finished the start step. but my train step is still running and my flow has not yet finished. So as a user who, for example, might be busy doing other things, this is like a very neat way for me to start understanding and knowing what is going on with my workflows, especially if those workflows have been deployed in production, or they might be using very business critical infrastructure such as GPUs or whatnot, which might be very costly and users need to be aware of, for example, what is going on. So now that I've shown, for example, the most basic ways to start inspecting what is happening with the bot, I wanted to give a small demo of how you can even start adding your own actions to the Slack bot. So coming here, let me give a. So for example, for the purpose of this demo, I had made a small GitHub action, like I made a small bot action via our Slack bot. So one of the interesting things with the Slack bot that we had open source is that you can create new actions via just following this opinionated structure that we have provided for extending the bot. So for example, at the moment, I'll download this, I'll clone this action that I created. And in this action, for example, we need to have a few we need to have a few init files that have a package util style import scheme. And that's it. Once we do that, we can easily create additional commands by just using a rule-based YAML file, which associates to individual commands in our actual code. So for example, over here, whatever message comes on Slack with the word download will invoke the download action on my Slack bot. So for example, my Slack bot at the moment consists of actions like download, example, 1 second. Yeah. So for example, this download action is invoked if whatever message I send my Slack bot consists of the word download as the start. So let me show you by, for example, installing this action to show how useful it can be. So for example, I just installed this action as a part of my Python path, for example, and I, for example, now run my bot server. So for example, as you see, my bot has registered this action to download stuff. Now that it has registered this action to download stuff, I can actually go to Slack and ask my bot to download the latest video, for example, from this pipeline that we have written. So I can literally ask my bot that, once again, yeah. So for example, right now, this command that I've written over here was something that I just built ad hoc recently for this demo, where I will ask the bot to download whatever the latest video that it has found for whichever run that got finished most recently. So for example, it figured out that, okay, this was the most recent successful run. And for this successful run, it discovered that, okay, this was the S3 artifact. This is the S3 URL where we had stored our artifact. And finally, I can just get the video from the artifact. And yeah, the bot is able to send it to me as a user. So the interesting thing, for example, with such types of actions is that users might have different kinds of use cases where they might want to see different kinds of information, or where their flows might need specific types of information monitored, like their flows might have specific information associated to them, which they might have to custom hack. So at least the way we have built the bot, it allows users to custom hack their own actions to to monitor things much better. And in short, like, yeah, I feel that this is the main gist of the entire thing. I think that's my main presentation. I wanted to know if you guys have more questions or thoughts.
Yeah, I guess for creating action, like if I wanted to make an action to share CPU resources on each job, like maybe walk through some of the steps I'd have to do to get that.
Pardon me, I couldn't hear you properly.
If I wanted to get like CPU resources for each step, like what would be like the way to like create a new action to do that?
Oh, you wanted to monitor CPU resources on your jobs. What would be, okay, so one way you can do that, I feel, is, so the custom hacking over there that might be required will be based on your cloud provider or where your jobs are being deployed of sorts. So for example, if you are running your workflows from a local machine on like an EC2, for example, on AWS, then you need to have this bot server, for example, running there. Once you have this running there, all you need to do is ensure, like, for example, just run some Python library that easily helps you get the CPU, for example, from that local machine. The other way of, for example, doing it where your code might be running on AWS batch or something is AWS has, I think, APIs which can help you get this type of information. So the only way users can then need to hack is that they just need to ensure that which job they are specifying, whatever flow they are specifying is they are able to map that to the right job on AWS patch, which I think is very, very possible given, but to do that exactly as you are saying, there would be some custom hacking needed where internally from Metaflow, stuff might not directly be available. But yes, you can. I would recommend that you should ask this question on our Slack channel because this is a very, very good question.
Can you post your Slack channel in the chat?
Oh, yeah. Sure.
So one question regarding the Slack bot, right? Because I saw that it was pretty easy to deploy it. Now, my question is like, does it use the same config.json file as your, like, okay, let me put it this way. Does it use the same, how does it handle namespaces and also which data store or which metadata store you're using?
Okay, great question. So first off, at the way we've built the bot is namespaces. There is no, like, none is the namespace. We don't put such individual user namespaces. But I'm sorry, can you repeat your second question? I'm so sorry. I just
so that's good to know that it's none because that means you'll get to see all the flows and runs. The other one is, for example, if I have multiple configs, right? So for our team, what we do is we use multiple profiles. So one of the Metaflow profile is the one that's running on, has everything on AWS, the data store and everything. The other is running locally. So we use that for the test pipeline. So how would it handle the data store? Like, is it picking up, can you provide the config.json address to the bot?
Okay, so yes, great question. So if you don't mind me asking, how do you, like, is your bot deployed as a container or is it like the way I did it right now, like a standalone service run on some machine?
We aren't using bot yet. This is the first time I'm seeing it, but like Metaflow, we use it on a local machine. We're not using batch, but our data store is on AWS.
Okay. That's perfectly fine. So one way you can go ahead with this is you just install the bot on that server, and for the profile part, this was at least even our internal discussion at the team. We were going to support such commands in the future where you can provide the profile name and it will resolve the right profile for you to figure out what flows you want to see. So at the moment, we have not added that tweak to select the right profile, but in the future we are planning to support such tools. So if again,
it's going to use the base profile in a sense, right? The default profile.
Yeah. So for example, if you're running it on your main, like if you're running it on your local machine on EC2, then it will use the config.json in the .metaflow config.
Okay, cool.
And otherwise it'll use environment variables, which is the second fallback. So if config file is not given, environment variables, or like if environment variables are given properly, config file might not be used. So
can you use this like the Slack bot to trigger flows?
So technically, yes, you like at the moment the feature is not been integrated yet, but this was something we have on our pipeline too. That's something we wanted to support in the future. But one thing I would recommend though is that you are making great feature requests, so please do come up on our channel to
So,
even
yeah.
voice these out, because we would love to build more on these types of things too.
Just out of curiosity, like if you're building it, like because right now you can't invoke a Metaflow pipeline, Metaflow using like Python command programmatically, right? It has to come from a command line. So would you be using like things like sub process or something?
It looks like that. So if we will do some form of invocation at the moment, it will not, it'll be through sub processes. Yes. Or like, so this is the other thing. This is where even we are still figuring a bit of the API semantics, but it's more on, if for example, not just deploying the flow on that machine, we have to even think about, for example, if you might deploy it on step functions, or if you might deploy it on some other like scheduling substrate, because Metaflow now has even like in very soon time, Metaflow will even be supporting Kubernetes and, for example, other workflow orchestrator like Argo or so on Kubernetes. So hence it's like a thing where we need to exactly chalk out what APIs we expose to users if they want to trigger flows from command line. But please do tell us like on our Slack channel if you're really interested in such features. We would really be happy to help. Yeah.
Definitely. Yeah. Thanks for sharing.
Are there any more questions?